Good day, students. This is the second class on chapter 2 polynomials for CBSE students pursuing grade, or I should say class 10, and it is also useful for class 9 students who are preparing for class 10. Having mentioned this, the title of this particular topic is relationship between zeros. They are also called as roots of a polynomial and its coefficient. Right? Now, to demonstrate, let me just take this polynomial p of x to be equal to 2x squared negative 8x positive 6. We are expected to find the zeros. Now, when they give you this, to find the zeros, you have to take this statement, let p of x be equal to 0. You have to equate it to 0, only then you will be able to find the roots. So this would mean, this symbol means implies. The meaning of this symbol means you will be using this many times whenever you are working with mathematics. This symbol means what? Implies. So this implies this entire expression 2x squared negative 8x positive 6 is equated to 0. Equated. That's the reason you call it as equation. This is an equation, but this is an expression. This is an equation. This is an expression. Have that in mind. Now this can be factored in many different ways. I'm going to factor it in this fashion. I'm going to disintegrate 8x as 6x and 2x added with this constant. This is equal to 0. Now I can take 2x out. If that be the case, I would get x negative 3. And over here I can take 2 out. In fact, I will take a negative 2 out, and that would give me x negative 3. You should have the same two components being present in this fashion. Now this is equated to 0. This is taken as a factor, so you will have 2x negative 2 is equal to 0. So from here, either x negative 3 is equal to 0 or 2x negative 2 is equal to 0. If 2x negative 2 is equal to 0, then 2x is equal to 2, then x is equal to 2 divided by 2, which is equal to 1. So you get the value for x to be as 1. This is one of the zeros. Over here, you move the 3 to the other side, you get x is equal to 3. So therefore, the solutions are 1, 3. The solutions are also called as zeros, or you can refer them as roots. Now, okay. Now what is the exact relationship between the roots and the coefficient? Well, there is something called as sum of the roots. Now, if you were to take the sum of the roots, there are two roots here, 1 and 3. The sum of the roots is equal to 4. How did we get this 4? We added 1 with 3. And what is 1? 1 is a root. What is 3? 3 is a root. So that is how we got 4. Now, take the coefficient of x. What is it? The coefficient of x is negative 8. You divide it by the coefficient of x squared. What is that? That is 2. So this quantity divided by 2 will give us negative 4, but it wouldn't give us positive 4. To get that positive 4, I place a negative sign here. Simple as that. Now what happens here? 2 divides 8 4 times. Negative of negative will give me positive 4. This positive 4 is same as the sum of the roots. So there is a formula. What is the formula? If alpha and beta, just imagine if alpha and beta, when I say alpha and beta, I'm talking about 1 and 3. If alpha and beta are the roots, then the sum, when I say sum, it means sum of the roots of alpha and beta, it is referred as alpha plus beta, is nothing but negative of coefficient of x divided by coefficient of x squared. Right? This is the all important formula. But the mathematical way, or I should say the algebraic way of writing this is little bit different. How different? Suppose you have a polynomial, say ax squared positive bx positive c. This is a quadratic polynomial, right? Now, if they are asking you to find the sum of the roots, then how would you write that? Let me state it here. Let alpha and beta be the roots of f of x. Then I will write the sum of the roots alpha positive beta as negative b divided by a. Now what is b? B is nothing but coefficient of x. Now what is a? A is nothing but coefficient of x squared, right? But we write it as negative of b divided by a. So have that in mind. Now after giving you the sum of the roots, there is something called as a product of the roots. This is called as alpha beta. How do you write it? That is equal to c divided by a. Now remember, c divided by a is called as product of roots. Product of roots. Now what is alpha positive beta? This is called sum of the roots. And what is the formula? Negative b over a. And over here, product of the roots is c divided by a. Now clearly, let me just go up here. If you were to take the product of the roots, now what is the product of the roots? 1 into 3 is what? Let me use the space. Now what is the product of the roots? Product of roots. What is that? That's 1 multiplied by 3. That's equal to 3. Now I can get the same tree from the polynomial. That is this polynomial. This is the polynomial. So what is the product of the roots? Coefficient or the constant term is nothing but 6 divided by coefficient of x squared. What is that? 2. So 2 divides 6 3 times. So that is equal to 3. You see that? The same tree I've got. Now we will have to do many questions related to this. Not only that, as you move up, suppose you are taking JEE entrance examinations. This will be a very important concept that you will have to focus on. Specifically, quadratic equation is a specific topic in JEE entrance examination. Suppose you have any interest of joining the IIT, you will have to give an entrance, and in mains as well as in the advanced, you will have quadratic equations being part of the specific topic. So make sure that you get a clear understanding of the concepts just I have just explained to you. So we'll move on. So let's do this question, students. They are asking us to verify the relationship between roots and coefficient. Given that p of x is equal to 3x squared positive 5x negative 2. Now solution, I'm starting the solution right from here. Okay, solution. So let 3x squared positive 5x negative 2 is equal to 0. So what I will do, I will split, always split the middle term. Split the middle term. So this is going to be 3x squared positive 3x positive 2x negative 2 is equal to 0. I take 3x out, I would get a x positive 1 here, and I would take 2 out, and that would give me x negative 1. Now my question to you is, can I proceed like this? Can I proceed like this? Answer me. Yes or no? Is it okay if I split 5x as 3x and 2x and then proceed from here? What's your answer? Okay, I hope your answer is no. We cannot proceed. Why? We have to factor it out. This is x positive 1, this is x negative 1. So the split that I have performed, 3x positive 2x, will not work. So we need to change our course. So I'm going to change the way how I split the middle term, right? So I'm going to try, instead of writing it as 3x positive 2x, I would like to write it as 6x negative x negative 2 is equal to 0. 6x negative x would give me positive 5x, right? That's always possible. So from here, I'm going to take 3 out, I'm going to take x out, I would get a x positive 2, that's fine. Over here, let me take negative 1 out, and that would give me x. Over here, it would be positive, and over here, followed by 2 is equal to 0. Or I'll state this to be implied. Instead of saying 2 equal to, you can use implied sign, which I've just explained to you a little earlier. So now you can clearly see the factors 3x of x positive 2. If over here you are taking negative 1 out, and that would give you x positive 2. For the fact negative 1 times x gives you negative x, negative 1 multiplied with positive 2 will give you negative 2. So now the split is perfect. X positive 2, x positive 2. Now let me use this part of the space. Now let me take x positive 2 out. That would give me 3x negative 1 is equal to 0. X positive 2 is equal to 0, or 3x negative 1 is equal to 0. From here, x is equal to 1 over 3 and x is equal to negative 2. So therefore the roots, what are the roots here? Therefore the roots, you can either call them as roots or zeros. Therefore the roots are negative 2 followed by 1 over 3. Now these are the roots. Now we need to establish a connection between roots and coefficient. How do we do that? In this following fashion, I'm going to start. Let alpha and beta be the roots of what? This is the polynomial, right? P of x, Then the sum of the roots is what? Alpha added with beta is equal to negative b over a, which is nothing but negative of the coefficient of x term. What is that? Coefficient of x. That's going to be 5, right? Divided by the coefficient of x squared. What's that? The coefficient of x squared is 3. So what have you got? You got negative 5 over 3. This is the sum of the roots. Now let us verify the sum of the roots. Let us verify this. So when you add the roots, you need to get negative 5 over 3. Okay. Now since x is equal to negative 2 and x is equal to 1 over 3 are the roots, their sum will be what? Their sum, negative 2 positive 1 over 3 will give us negative 6 positive 1 over 3, which is nothing but negative 5 over 3. Right? So clearly what do you see here? Clearly this and this, they are one and the same. Right? So clearly you have established this first fact. Now also, hence they are same. Hence they are equal. You can write the word equal. Also product of the roots. So what is the product of the roots here? Alpha times beta is equal to c divided by a. And that is equal to c. What is your c? Your c is negative 2. Here a is 3. So this is negative 2 over 3. So let us verify. Let us verify this. So how are you going to verify? Since x is equal to negative 2 and x is equal to 1 over 3, their products. Their product is negative 2 times 1 over 3, which is equal to negative 2 over 3, which agrees with our product of the roots formula, right? So this and this are one and the same. So this is the connectivity that we have given between the roots and the coefficients, right? Every time we write a formula, the coefficient is actually present there. When I say C over A, it's nothing but the coefficient of the constant term divided by the coefficient of the x squared term. So that is understood. So you don't have to explicitly keep stating it. Let's do example 2. The question wants us to find the zeros for this polynomial. I'm writing it as p of x is equal to x squared positive 7x positive 10, and we are asked to verify the relationship between zeros and the coefficient of p of x, right? So this is what is given. Solution, let me write that down. Solution, we got p of x is equal to x squared positive 7x positive 10. This means I need to take x squared positive 7x positive 10 is equal to 0. Now what I wish to do, I would like to split this as x squared positive 2x and 5x with the 10 equal to 0. So I take x out, x positive 2, I take 5 out, this is x positive 2. You need to get the same factors. So this is going to be x positive 2 times x positive 5 is equal to 0. This means x is equal to negative 2 and x is equal to negative 5. Therefore the roots are negative 2 comma negative 5. Now verification, right? This is the verification. If alpha, let me just take it like this. Let alpha, in this case I'm going to take minus 5, and beta negative 2 be the roots, of p of x. Then the sum of roots is what? Alpha plus beta is given as negative b over a, which is nothing but, what is my b? In other words, the coefficient of x is 7 and a is 1, which is equal to negative 7, right? Now if I were to take the value of alpha as negative 5 and beta as negative 2, negative 5 added with negative 2 is exactly equal to negative 7. You're able to watch that? Now also the product of the roots, alpha times beta is equal to c over a. Now what you can do, if in case, if you want, you can write that over here. What is c? C is nothing but the coefficient of constant divided by coefficient of x squared term. So similarly you can write that down here. You can write it over here. This is nothing but the coefficient of x term divided by coefficient of x squared term, right? So which is equal to 10 divided by coefficient of x squared is going to be 1, which is equal to 10. So similarly, clearly you can actually see that here. The product of the roots, negative 2 multiplied with negative 5 will give you 10, right? Probably you can state that from the roots like this, from the roots double colon, negative 2 times negative 5 is equal to negative 10. Actually corresponds, it's positive 10. This is going to be positive 10. This corresponds with the value that we just got here. Let's do this question, students. This is example 3, and we have been given this. The polynomial is x squared negative 3, and we are asked to find the relationship. Find the relationship between the roots. When we say roots, it's the zeros also, right? It means, and the coefficients, right? Now what I wish to do is, this is given that p of x be equal to x squared negative 3x, and let us take x squared negative 3 is equal to 0. This means I can write x squared negative 3 as x negative root of 3 multiplied with x positive root of 3. Now how am I able to write this? Remember, a squared negative b squared is a negative b times a plus b. This is the formula you will have to know. So this is going to be x into x, x squared. Negative into positive will be negative. Root of 3 times root of 3. Root of 3 multiplied with root of 3 is equal to 3. And that's the reason I'm able to write it like this. So from here, I can have x negative root 3 is equal to 0, or x positive root 3 is equal to 0, which means x is equal to root of 3, x is equal to negative root of 3. So these are the roots. So therefore I can state here the solution set is nothing but negative root of 3 comma positive root of 3. That is the solution for this particular polynomial. Now if alpha, coming to the verification part, okay, verification. If alpha and beta are the roots of p of x, then the sum of the roots, sum of roots, which is nothing but alpha added with beta, is equal to negative b over a, which is nothing but negative of coefficient of x divided by coefficient of x squared. So that is equal to negative of, what is the coefficient of x? Do we have a coefficient of x here? 0 divided by coefficient of x squared is what? 1, which is equal to 0, right? So that's a solution there. Now just check out the roots. If you were to sum them up, negative root 3 added with positive root 3 is for sure going to give you 0. So the validity stands firm there. Next, the product of the roots. Product of the roots. So what does this mean? This means alpha multiplied with beta is equal to c divided by a. What is that? That's nothing but coefficient of constant divided by coefficient of x squared. So which is equal to coefficient of constant. What is the coefficient of constant? What is the constant here? Constant here is negative 3, right? Let us place that negative 3 divided by coefficient of x squared. What is that? That's going to be 1. So what do you get? Negative 3 will be the outcome, right? Now let's go to the values. If you were to multiply root of 3 times negative root of 3 into root of 3 will give you 3, but there is a negative sign here that will also be accompanied, right? So that's the reason we are getting negative 3. So this is a lovely question. Students, let us move on to do the next one. Now this is example 4. Now this is slightly different. Now it says, is asking us to find the polynomial. This is also a very important question. If you are preparing for entrance examination, any form of entrance examination, this will be a very important question. Find the polynomial. They are asking us to find the polynomial, right? And in this case it's a quadratic polynomial. Okay, given that the sum and product of zeros will also be mentioned as roots, are -3 and +2. So solution set, I'm going to start the solution in this following fashion. Let alpha and beta be the roots of the polynomial p of x. Then we know WKT stands for, we know that. You will have to familiarize yourself in using this WKT. We know that. What do we know? Alpha added with beta is equal to -b over a, and that is actually given to us, right? Two roots are actually given to us. So this is equal to, the sum is -3. Now this would mean I have -b over a is equal to -3, right? This is what I've got. Now the much important question comes here is, when is this possible? When is it possible for us to get a -3? We need to get a -3. So that would mean what should be the value of a and what should be the value of b. That is one part of the question, but we are not yet finished. Also the product of the roots. Also the product of the roots. We know that the product of roots. So what do we know? Alpha beta is equal to c divided by a, and that is given to us as 2. So this would mean c over a is equal to 2. So when is this possible? Now this will be possible for a certain value of a and for a certain value of c. Now more than anything else, we have to ensure that there is a positivity here. Now I need to get -3 here. Now -3 is possible if b is equal to, say, if I were to take b is equal to, say, 6 and a is equal to -2, then it's possible. But watch here, if I were to take a as -2, then c divided by -2 is equal to 2, therefore c is equal to -4, which is not possible. We cannot have a c as -4 because that would contradict the value given to us. So coming back, this possibility is ruled out. So the only possibility is taking the value of b to be as 3 and a to be as, say, -1. If I were to take a to be as -1, then that will again contradict our c, because the value given is 2. If I were to take a as -1, then c will be -2, right? So -2 divided by the value of a. So let me just take a as -1 and see. If I were to take a as -1, then c divided by -1 is equal to 2. Therefore c is equal to -2. Now if c is equal to -2 and my a is equal to -1, then of course I'm getting a value of 2 here. So this can be okay, right? This is fine, but there will be one problem over here. What is it? Suppose I were to take, let me use little bit of this part, b over a, right? So b over a will be 3 divided by -1, which is going to be -3. That's fine. But apparently we are not taking b over a, we are taking negative of b over a. The moment I attack the quantity with a negative sign, I would convert this into a positive value. So clearly a is equal to -1 is ruled out. So if a is equal to -1 is ruled out, the only possibility that is left with us is a is equal to +1. If a is equal to +1 and b is equal to 3, then clearly because of the formula, this would give us -3. And there wouldn't be any issue in this case, because a is equal to 1 means c is equal to 2. When c is equal to 2, 2 divided by 1 will in turn give us our value of 2, which is present here. So this would mean A is equal to 1 and C is equal to 2. And in this case, A is equal to positive 1 and our B value is equal to 3. So I have actually got the value. Now the much important question is to extract the polynomial. So just to give you a recap, A is equal to negative 1 will not work. A is equal to positive 1 alone will work. Right? So when A is equal to positive 1, C will definitely be equal to 2. So we have thus obtained the value for A, B and C. Now if I were to take the polynomial P of x to be as ax squared positive bx positive c, then all I need to do is to substitute the values of A. So A in this case is 1, so it's going to be x squared, B is 3x and our C is equal to 2. So this is the required polynomial, which is the required polynomial, right? So that is the solution for this question. Of course, there are some technique of trial and error used. So the technique is trial and error, but you don't have to be worried about that. As you progress, you will be able to obtain all these techniques. Okay, so now that we have got, let us just move on to looking into a polynomial which is not of degree 2 but of degree 3. So P of x is equal to, say, 2x cubed negative 5x squared negative 14x positive 8. Now I'm going to give you a very important formula. You will have to hold on to the formula because this formula would be occurring redundantly in many competitive exams. So let me give you the formula. In this case the degree is 3, right? So I'm going to state it here. Let alpha comma beta comma gamma be the roots of P of x. Then sum of the roots, I'm writing it like this, alpha positive beta positive gamma is equal to, now this is of the form ax to the power of 3 positive bx squared positive cx positive d. So this is the form we will be comparing. So this is equal to negative b over a. In this case it's going to be negative of negative 5. My a is 2, so this is going to be 5 over 2. So have that in mind. Now this is sum of the roots taken one at a time. Now this is going to be sum of the roots taken two at a time. So alpha beta positive beta gamma positive gamma alpha is equal to, this I have taken it as minus b over a. So this is going to be positive c over a, which is going to be positive of, my c in this case is negative 14 divided by 2, which is going to be negative 7. Remember, c over a. Now roots taken 3 at a time. So that's going to be alpha beta gamma, which is equal to minus plus and minus d over a. So what is d over a? Place a negative sign. Take the value of d. A, b, c, d. D is going to be 18 divided by 2, which is going to be equal to negative 9. So make sure to check these values. Students, let's do example 5. It's given as 5 star. And they have said this is not important for examination point of view. But however, this is very important for future. For all entrance examination, this problem, the concepts dealt in this problem will be reoccurring. So I would like to suggest that you pay specific attention to this particular question. Now what is the question? The question states that verify that 3 negative 1 comma 1 over 3 with a negative sign are the zeros of the polynomial. A polynomial is given, a cubic polynomial is given. P of x I am indicating, and that's going to be 3x to the power of 3 negative 5x squared negative 11x negative 3, and we are asked to verify the relationship between zeros and the coefficients. This is what is required. Now solution, I'm starting the solution. right? Given, what is given? Given P of x is 3x to the power of 3, negative 5x squared, negative 11x, negative 3. Now, to verify, let me state here, if x is equal to 3 is a root or 0, then P of x is equal to 3 will be equal to 0. So this is the most important concept that you will have to focus on, right? So I'm going to substitute x is equal to 3. So this is going to be 3 of 3 raised to the power of 3, negative 5 times of 3 squared, negative 11 times of 3, negative. This is 3 3s are 9. 9 times 3 is 27. So 3 times 27, 5 times 9, this is 33, negative 3. Now this is equal to 7 3s are 21, 2, 3 2s are 6, 7, 8, negative 45, negative 33, negative 3. That's going to be negative 36. Now 45 added with 36, what is that? That's going to be 181 with a negative sign and 81. This is equal to 0. So this means x is equal to 3 is indeed a 0. You can just state it. Also, when x is equal to, what is the next root they have given? Negative 1. Therefore, P of x is equal to negative 1 is nothing but substitute negative 1 in this. This is 3 of negative 1 raised to the power of 3. Negative 5 of negative 1 raised to the power of 2, negative 11 of negative 1 followed by negative 3. This is going to be negative times 3 is negative, this is positive, negative 5, this is positive, this is negative. So this is going to be 5 added with negative 3 is negative 8, negative 8 added with negative 3 would be negative 11, added with 11 will give you 0. So this means x is equal to negative 1 is indeed a 0. Okay, so now, okay, we check. So you can simply state here, check 1 and then check 2 and then when x is equal to negative 1 over 3, check 3. So you can use some identification, right? For the examiner, you need to make sure that the examiner is able to see everything that you are doing. So therefore P of x is equal to negative 1 over 3 is equal to 3 times of negative 1 over 3 raised to the power of 3, negative 5 times of 1 over 3 raised to the power of 2, negative 11 times of negative 1 over 3, negative 3. This is going to be what? I can cancel a 3. Probably let me write this down. 3 divided by 3 3s are 9, 9 3s are 27. You got a negative sign and negative, this is going to be positive. So no influence or no impact of this negative sign there. So negative 5 over 9, positive 11 over 3, negative 3. So now you need to get some LCM. You need to show the step. So 27 is the LCM. This is negative 3. 9 divides 27 3 times. 3 5s are 15. 3 divides 27 9 times. So this is going to be 99 and this is 1. So 27 times 3, that's going to be negative 81, right? So 81, you can use a rough side. 81 added with 15, that's 6, and 96 added with 3, that's going to be 99. So you got a 99 and giving us 0, right? So this means you can write it down. X is equal to negative 1 over 3 is indeed a 0. So you have verified these quantities are indeed the zeros for this polynomial. Now the next step is to prove the verification between 0 and the coefficient. Okay, maybe you can just show here verification of the relationship between zeros and coefficient, right? So probably you can give some underlining to show to the examiner. So given, what is given? P of x, you can write here GVN stands for given. Given, what is given? 3 times x to the power of 3, negative 5 times x squared, negative 11x, negative 3. let alpha, beta, gamma be the roots of p of x, right? So sum of roots taken one at a time. So alpha, positive beta, positive gamma is equal to negative b over a, which is nothing but negative of negative 5 divided by 3, right? This is what you've got. So this is going to be positive 5 over 3, right? So you can write that down. This is equal to 5 over 3. Now, how are you going to show that this is indeed 5 over 3? Now we got 3 roots, right? We got a 3 added up with negative 1, added up with negative 1 over 3, and on the right hand side you got 5 over 3, right? This is the check. You can just show the check there. So if you were to take the LCM as 3, what do you get? This is 9, negative 3, negative 1, which should give us 5 over 3. I'm using this part of the page. 9 negative 4 will give you 5 divided by 3 is equal to 5 over 3, right? So that really shows that there is a relationship between the roots and the coefficient, which we have just displayed there. Now next is product of roots 2 at a time. 2 at a time. You can write that. So what is that? Alpha beta plus beta gamma plus gamma alpha. That's 2 roots at a time. And that is equal to, we started with minus b over a. This is going to be c over a. Now what is c over a? This is a, b, c. That's going to be negative 11 over 3. So place the product of the roots. Alpha is what? If I were to take, let me just write down here. This is the rough side. You remember I mentioned to you, have a rough side. Alpha is equal to 3, beta is equal to negative 1, and gamma is equal to negative 1 over 3. So roots taken 2 at a time. So it's going to be 3 of negative 1, positive of negative 1 times negative 1 over 3, positive of negative 1 over 3 times 3 is equal to, should produce 11 over 3 with a negative sign. Now this and this gets cancelled. I get negative 1. This is going to give me positive 1 over 3, and this is going to give you negative. This should produce me 11 over 3. Let me use this part of the page. Now this can be added, giving me negative 4 added with 1 over 3, right? So 4 times 3 is 12 with a negative sign added with 1 divided by 3, which is negative 11 over 3, which is indeed equal to my negative 11 over 3. This should be negative 11. That should be a negative sign. So this is indeed equal to negative 11 over 3. So we have proved this, right? This is true. Now next is product of roots. Product of roots taken 3 at a time. So that means alpha, beta, gamma is equal to, this is negative b over a, this is c over a, next one should be negative d over a. So what is d? A, b, c and d. So it's going to be negative of negative 3, my a is 1, giving me positive 1. So if I were to take the roots 3, negative 1, 1, negative 1 over 3, what is that? 3 times negative 1 times negative 1 over 3. This should give me positive 1. Negative, negative, positive, 3 and 3 gets cancelled. Therefore, I get 1 is equal to 1. So I have completed all of the verification. So what you can do is you can box this for the understanding of the examiner. And over here, you can just state here, which is equal to negative 11 over 3. You can also box this, right? So that is a very good problem. It's a very good question, and we have successfully completed it. So let's move on. Now we got exercise 2.2. It's very simple. I want you all to do exercise 2.2. If you have any questions or concerns, place them in the comment box. Right? If you are feeling that some question is a challenge, write to me on the comments. I will help you. Okay, now let us move on to the next one. This is called a division algorithm. Right? Division algorithm. Very important topic. How to divide a polynomial by another polynomial. So in this concept, you will have to know that you are given a polynomial p of x, and you're dividing it by another polynomial. So in this case, you are given p of x is equal to 2x squared positive 3x positive 1, and you are asked to divide it by another polynomial x positive 2. So this is called as long division. I also called as long division, right? Long division, right? So let me just show you. So you can just place the division sign like this, and then 2x squared positive 3x positive 1, and then you got x positive 2. Now foremost you draw a line. Now before you could start, place 2x squared here. Just place it like that. Now what quantity should you place here so that that quantity multiplied by the first quantity over here produces 2x squared? Come on, give me your reply. The question is, what quantity should you place here so that that quantity multiplied by this quantity gives me 2x squared? Obviously it's going to be 2 times x, because 2 times x gives me 2x squared. Not only that, we need to get a positive sign, so the positive sign remains there, right? So that is the step 1. That is how you need to do. Of course 2x should also be multiplied by 2, so that is going to give me 2x times 2, which is going to be 4x. Now you should change the sign. Remember, the signs that you see here is plus. They should be like signs in nature, but you have to change your sign. How do you change the sign? You got a plus here, change it to minus. You got a plus here, change it to minus. Now you add them. You add 2x squared with negative 2x squared. What happens? This 2x squared gets cancelled. It has to get cancelled, and you should get 0. You don't have to specify 0 there. Now 3x minus 4x, that's going to be negative x. Now you place that 1, bring that 1 down. Now you draw a line, and then you place negative x. You need to get negative x. Now the question is, what should you place over here so that that quantity multiplied by this x gives me negative x? In all fairness, I need to get a negative x there. So the only way it's possible is through negative 1. Negative 1 times negative positive x gives me negative x. Negative 1 times positive 2 will give me negative 2. Now we change the sign. You got a negative sign, change it to positive. You got a negative sign, change it to positive. Negative x added with positive x will result in 0. You don't have to place the 0. Positive 1 added with positive 2 will give me 3. So this is how you divide. Now we got two quantities here. This is called as the quotient. And this is called the remainder. Now any polynomial, right? Any polynomial p of x divided by q of x can be written in this fashion. So p of x divided by q of x can be written in this fashion. So in this case, you got the quotient, right? Place that plus the remainder divided by x positive 2. So this is how you need to write. Now ultimately, if you were to multiply these two things, you will exactly get back this quantity p of x divided by q of x. So remember this. This is the representation that will come in very much handy, right? So if you were to represent this in some other way, suppose you want to represent this in some other way, then you can also represent it in this following fashion. That means the quotient multiplied by the divisor plus the remainder, right? Now whatever I placed here, I've given it in formula fashion. This is exactly this, right? Now suppose you're going to represent it like this. So 2x minus 1 multiplied with x positive 2 plus 3, right, divided by x positive 2. Now what you got on the left hand side? On the left hand side, it's the polynomial 2x squared positive 3x positive 1 divided by x positive 2, right? Now x positive 2, x positive 2 can be cancelled, giving us what? Giving us 2 times x squared positive 3x positive 1 is written as 2 times x negative 1 times x positive 2 positive 3, right? So in fact, what are we trying to show you here? There is always a way by which we can factor the polynomial as quotient times the divisor plus the remainder. So this is the all important formula that you will have to have in mind. So having mentioned this, let us familiarize ourselves with the concept by working some problems. Okay, this is example 7. We've been given 3x to the power of 3 positive x squared positive 2x positive 5. This is divided by 1 positive 2x positive x squared. Always they will give terms like this, but we will have to arrange them. And what I will do, I will just draw the division sign, place in the quantities. I start with the higher power 3x squared, followed by the next power 2x squared, followed by x squared, followed by the next power, which is degree 1, and finally the constant. And now you place the power in actually in this fashion. Highest comes first, followed by the next term, which is 1 less than the previous term, and subsequently you have to end with the constant term. So this is how you need to write. So foremost, you draw a line. Immediately you place 3x cubed. Now find out what number should you place here, so that that number multiplied by the first term produces 3x cubed. Now clearly I know that 3 should be there and an x should be there, because 3x multiplied with x squared will give me 3x cubed, right? Followed by 3x multiplied with 2x, that's going to give me 6 times x squared, followed by 3x multiplied with 1, that's going to be 3x. Now you need to change the sign. Make sure the terms, the leading terms, have got like signs. You have a positive sign, it should be positive. You have a negative sign, they should be negative. But in this case, it's only positive, so clearly change the sign. You got a positive sign here, change it to negative. You got a positive sign, change it to negative. You got a positive sign, change it to negative. Now clearly the two terms 3x cubed and 3x cubed can be cancelled, giving you or leaving you with x squared negative 6x squared, that's going to be negative 5x squared. 2x negative 3x, that's going to be negative x. Now you bring down the constant term 5. Draw a line. Now you immediately place negative 5x squared. Now the all important question comes is, what should you place here so that the number multiplied with the leading term produces 5x squared with a negative sign? Obviously it's going to be negative 5. Negative 5 multiplied with x squared would give me negative 5x squared, followed by negative 5 times 2x is going to be negative 10x, followed by negative 5 times positive 1 is going to be negative 5. Now you change the sign. You have a negative, change it to positive. You got a negative, change it to positive. You got a negative, change it to positive. Now you add them. So what happens when negative 5x squared is added with positive 5x squared? They get cancelled. You don't have to place 0 there. Now negative x is added with positive 10x. Now this would give you positive 9x. Positive 5 added with positive 5. This would give you positive 10. That's all. You don't have to do or reduce it still further. Why? It's not possible for you to reduce it, because the degree of x is 1, the degree of x is 2. So what do you need to do? Therefore, the factored form of 3x cubed, positive x squared, positive 2x, positive 5 is equal to, what is the quotient? 3x negative 5 multiplied with the divisor, that's x squared positive 2x positive 1. And what you got? This is the remainder, 9x positive 10. It's always better to place the remainder in this fashion. Now you can either write it as quotient first, then comes the divisor, or the divisor first, then comes the quotient. It doesn't matter, because a times b is same as b times a, right? So we have got that. Now you can also perform the check. You can multiply it and you will get back the original form. You will get back this original quantity, right? So that is for you. You will have to multiply these two things and add it up with this, and then see that you're getting the left hand side, and give me your comments and your results. Okay, the next example, let me do this example number 8. Example number 8 is, they're asking us to divide 3x to the power of 2 negative x cubed negative 3x positive 5 by x negative 1 negative x squared. You see how they have confused the terms. This is how they will give. you have to take the first term, the largest term, and place it in that order. Negative x cubed followed by 3 times x squared followed by negative 3x followed by 5. The first x squared comes first, x squared, next comes x followed by negative 1. Now you draw a line, place negative x cubed. Now what should you place here so that this number multiplied with negative x squared produces negative x cubed? Clearly that's going to be positive x. Positive x multiplied with negative x squared produces negative x cubed. Now continue on with the product. X into x will give you x squared. X into negative 1 will give you negative x. Now change the sign. I got a negative sign, change it to positive. I got a positive sign, change it to negative. I got a negative sign, change it to positive. Now add these two quantities together. Obviously this one will vanish. You got 3x squared added up with negative x squared. That's going to be 2 times x squared. Negative 3x added up with x will give you negative 2x. Bring the 5 down. Draw the line. Place 2x squared. Now question yourself. What should I place here so that the number multiplied with negative x squared produces 2x squared? Obviously it's going to be negative 2. Negative 2 multiplied with negative x squared produces positive 2x squared, right? Now move on. Negative 2 into positive x will give me negative 2x. Negative 2 into negative 1 will give me positive 2. Now it's time for you to change the sign. Change the sign. Minus, plus, plus, minus. Negative 2x squared and you have a positive 2x squared. They cancel and vanish. You got negative 2x added up with positive 2x. They cancel and vanish. You got 5 added up with negative 2. That's going to give me 3. So therefore, what have you got? X to the power of 3 with a negative sign. Write down the polynomial. Positive 3 times x squared, negative 3x positive 5 can be written as, now I'm just writing it in the fashion that I've just mentioned to you. You can also use this way of writing. First the divisor, negative x squared, positive x, negative 1. First the divisor and then multiplied with the quotient, which is x negative 2, followed by the remainder. So this is the solution for the question. Negative x squared, positive x, negative 1 multiplied with x negative 2, positive 3. Now if you were to multiply it and check, you will get back the left hand side, right? You will get back the left hand side. Now let's move on to the final example. Example number 9. Now it says find all the zeros. Let me just write this down. Find all, this is a beautiful question. Find all the zeros, right? Zeros of 2 times x to the power of 4, negative 3 times x cubed, negative 3 times x squared, positive 6x, negative 2. If 2 of the zeros, right? If it's 2 zeros are plus root 2 and negative root 2, right? Now this is a beautiful question. Why is it beautiful question? Questions like this would be asked in your entrance examinations. Suppose you want to join medical schools or engineering schools or fashion technology, all these high-end schools, elite schools, they will conduct entrance examinations, and these entrance examinations are of competitive nature, and these examinations will definitely contain questions of this magnitude. So that is a clue for y'all to prepare. So it's a very good time for y'all to start preparing from now onwards. 10th standard onwards, you can, from 10th class onwards, you can start your preparatory, and by the time you hit your 12th standard and sit for your examination, without any doubt, you know that you're going to get it, right? There is no way that you need to be on a limbo, right? For sure, because everything needs preparation, and this is a good time. So having given you that words of encouragement, let me just go on with the solution. Now, given that, this is how you need to do this. Given that root of 2 and negative root of 2 are the roots of p of x, right? So this would mean x negative root 2 and x positive root 2 are the factors of P of X, right? So now we will divide P of X by x negative root 2 multiplied with x positive root 2. X negative root 2 times x positive root 2. What is that? That's nothing but x squared negative 2, right? You need to divide that. So when you divide it, you will get the other quantities. So let me just start the division. X squared negative 2, draw the division sign, write the polynomial 2x to the power of 4, negative 3x to the power of 3, and negative 3x to the power of 2, positive 6x and negative 2. Now draw a line and place this 2x to the power of 4. Now the question is, what should you place here so that you get 2x to the power of 4? Definitely it's going to be 2x squared. 2x squared times x squared will give you 2x to the power of 4. 2x squared times negative 2 will give you negative 4 times x squared. Now you change the sign. This is positive minus, this is minus plus. This can be cancelled, and this will give you negative 3x squared added up with positive 4x squared. That's going to be x squared. Bring the terms, negative 3x squared down. Now draw the line, place x squared here. Now query yourself, what should you place here so that that multiplied with x squared gives you x squared? Clearly it's going to be positive 1. 1 multiplied with x squared gives you x squared. 1 multiplied with negative 2 will give you negative 2. Now this is x to the power of, oh, there is one small issue there. Now what did I do? I have actually treated this as x to the power of 2, but apparently this is not x to the power of 2. No, this is actually x to the power of 3. I am just realizing it now. Probably because of my heavier ink, it got disguised. So this is actually x to the power of 3. I cannot add these two things together, right? I cannot add these two things together. So I have to add this quantity with this quantity. So the addition is actually performed over here. So what I will do, I will just redo this in this side. Okay, so it's better. So let me just write that down, the polynomial 2x to the power of 4, negative 3 times x to the power of 3, negative 3x squared, positive 6x, negative 2, and we are dividing it by x squared, negative 2. So we start off, draw a line, place x to the 2x to the power of 4. So what should I place here so that I get 2 times x to the power of 4? Clearly it's going to be 2 times x squared, right? 2 times x squared gives you 2x squared to the power 2x to the power of 4, right? So this is fine, but 2 times x squared with negative 2 will give you negative 4, right? You're going to get negative 4. Place it under this quantity, under this x to the power of 2, under 3x to the power of 2, you place this quantity, negative 4 times x to the power of 2. Now you change the sign. This is plus minus, minus, you plus. Now this one gets vanished. This one is brought down directly, negative 3 times x to the power of 3. Now this one is negative 3x squared added up with positive 4x squared. That is going to give me positive x squared. Next you bring the 6x. You draw the line. Now you need negative 3 times x to the power of 3. You need this. So what should you place here? So that this quantity multiplied with this quantity gives me negative 3 times x to the power of 3. And that is without any doubt negative 3 times x. So negative 3 times x multiplied with x squared gives me negative 3 times x cubed, followed by 3 times x with the quantity 2. That's going to be positive 6x. Now I cannot place a positive 6x here, right? I cannot place it under this quantity. Now this is actually 6x, right? I have to place positive 6x over here, right? I have to place positive 6x over here under the term 6x, or I should say under the term x. Now you change the sign. This is minus, you change it to plus, and this is plus actually, you change it to minus. Bring this x squared down, and this gets cancelled, this gets cancelled. 6x added with negative 6x, this also gets cancelled. You got a negative 2, so bring that negative 2. Now place the line, the degree is same. So what should you do to get x squared here? So you place the x squared. What should you do to get x squared here? So that is the line of action which we need to pay attention to. naturally, if I were to place positive 1, 1 multiplied with x squared will give me x squared. 1 multiplied with negative 2 will give me negative 2. So these two gets cancelled, giving me 0 as a remainder. Whenever you get 0 as a remainder, this means 2x squared negative 3x positive 1 is a factor, right? Now to get the roots, you have to equate 2x squared negative 3x positive 1 to be equal to 0. You got to do that. Now split the middle term. To factorize, you split the middle term. Split it as negative 2x and negative x positive 1 is equal to 0. Now from here you take 2x out. This is going to be x negative 1. Fair enough. 2x into x gives me 2x squared. 2x into 1 gives me, with a negative sign, gives me negative 2x. And I get a negative x and a positive 1. So what I will do, I will take a negative 1 out. That would give me a x here and a negative 1. Negative 1 times x gives me negative x. Negative 1 times negative 1 gives me positive 1. This is equal to 0. Let me use this part of the page. So from here I can take x negative 1 as a factor. That would leave me with 2x negative 1 equal to 0. This means x negative 1 is equal to 0 or 2x negative 1 is equal to 0. From here I get x is equal to 1. From here I get 2x is equal to 1. Therefore I get x is equal to 1 over 2. So this would mean the total number of roots or the total roots of the polynomial p of x is equal to, you can write the roots down. So what are the roots? In fact, we were given already root of 2 and negative root of 2. So I will start with negative root 2 and then I will state 1 over 2 and then I will say 1 and then followed by root 2 are the roots, right? So we have actually found all of the roots, right, for this particular question. So this is the completion of this particular problem. So you need to be a little bit careful in this case and not make any slips. So you got exercise, the last exercise for this is exercise 2.3. It's all simple. I would like you all to do that exercise and post your solutions, right? Specifically, it would be much better even if you could complete exercise 2.4 and ask me your queries. Okay, students, thank you very much. Enjoy your day and be more productive until we meet again in the next class. Thank you.